Hello dear children, in the previous classes we discussed types of isotopes, radioactivity, properties of alpha, beta, gamma and alpha decay, beta decay, gamma decay. So far we made two parts. So today is the third part of unit A. Of course today we are going to complete this unit A. The two links like the links related to the previous two classes, that is the two parts, will be given in the description. Just watch those videos. So that what will happen? So there will be a continuation for you also, and you will get a complete grip on the unit A of the radioactivity. Fine children. So in today's class, before going to discuss today's class, let us recall the important points whatever we discussed in the previous class. Especially in the previous class, mainly we focused on alpha decay, beta decay, gamma decay. Children, what will happen in alpha decay? What will happen in the beta decay? And what will happen in gamma decay? Children, during alpha decay, the atomic number is decreased by 2, whereas mass number is decreased by 4. When come to the beta decay, during a beta decay, atomic number is increased by 1, whereas there is no change in the mass number. Then what about gamma decay? During a gamma decay, there is no change in atomic number, even mass number also do not change. Only there is a change in the nucleus energy. This is a very important. So in today's class, we will be covering what are radioisotopes, applications, very important. Then we cover source of harmful radiations and the harmful effects of radiations and the precautions to be taken while handling the nuclear energy and even while establishing the nuclear power plant. And finally, we discuss the background radiations. Fine children. So before that, just try this question. It's based on the alpha decay and beta decay. One question will be given. Just try this. X is an atom whose atomic number is, let us say it's 94, and here is some 298 is given, and here it emits one alpha particle and changes into Y, and whose Y, then Y emits one beta particle, changes into what we can say some P, let us say P, and this at nucleus P has some atomic number and it has a mass number. So this is homework question for you. It is based on purely alpha decay, alpha decay, beta decay, and okay, only here gamma is not alone, only alpha. See, try to understand. This nucleus emits alpha particle and there will be a change in the atomic number, there will change in the mass number. Again it emits beta particle. Then finally it is a nucleus. And what is the atomic number Z value here? What is the mass number? Just think about alpha decay, think about beta decay, then you get the answer, then comment your answer. So just I will check it. Okay, and I will reply and I will tell you it is right or wrong. Is it clear? Just note on this question just for your practice children. So that if you can do these kind of questions, what happens, you get bit confidence you will get that yes, we are doing. It's just not like learning what is alpha decay, what is beta decay, what is gamma decay. Anyone can buy hat. But thing is that when you can do these kind of questions only, yes, you will get a grip, complete grip on that particular concept. Clear? Fine. Chalo. Now let us move to the today's session. So as I told you that today first we are starting with the radioisotopes. First let us see what are radioisotopes. Children, let us see what are radioisotopes. Children, I think in a first class even we discussed about the types of isotopes. Then we discussed stable isotopes and unstable isotopes. So today's class is related to that only actually. Okay, now fine. So some isotopes of an elements whose atomic number is, children, whose atomic number is less than 82. See, already we know very well that the atoms with atomic number more than 82 are unstable. So obviously they will be in radioactive in nature. But even children, the atoms with the atomic number even less than 82 in some isotopes. So what happens, the number of neutrons are greater than that of the protons, so that they are found in radioactive nature. They are found in radioactive in nature. This is very important, radioactive in nature. So mostly what you have to see, this is actually the number of neutrons are greater than that of the number of protons. Such a isotopes are found to be in a radioactive nature. Those isotopes only we can call it as a radioisotopes. Let us see the example. So example for radioactive isotopes. Here carbon C6 14, phosphorus 15 32, potassium 19 40, and you can take even cobalt, very important to us, 27 60, like this. Okay, now so if you can see in each and every this one atoms, number of neutrons are greater. Let us see here. In a carbon, children, number of protons are 6. Okay, number of neutrons, that is 14 minus 6, how much? 8. Okay, let us check here also. Number of protons are 15. Number of neutrons are 32 minus 15, it will be 17. Next, come to the potassium. Number of protons are 19 and number of neutrons are, if you can see, it's a 21. Okay, and come to the cobalt. Here number of protons are 27 and whereas number of neutrons are 60 minus 27 is a 33. So if you can see, the number of neutrons are greater than that of the number of protons. These kind of isotopes only we can call it as a radioisotopes. Children, fine. So here now we'll see the applications, children, here. So here many applications which we have. So the applications of radioisotopes are mainly classified into 3 categories. First one is medical, second one is scientific, third one is industrial. So why I am saying, children, in general, in exam, for suppose if they'll ask you to write the applications of radioisotopes, in general you can write. But sometimes, specially they are asking, mention the application of radioisotopes in medical field, in an industrial field, in a scientific field actually. So you must be very careful. Clear? Fine. So now we discuss the applications. Plastic, so etc. also you can write. Fine, children. So here, as I told you, that we have 3 applications, 3 areas: medical field, scientific field, industrial field. Children, once again telling you, if they'll ask you in general, you can write any applications, but if they'll mention you specially, so you have to see, if it is a medical field, you have to write medical field only, scientific field means scientific field, industrial means industrial. Come to the medical field, children. So we know that here cobalt 60 is a powerful source of gamma radiation. Cobalt 60 is a powerful source of gamma radiations. So whatever the gamma radiation which is emitted is used to treat the cancer. It's very important. Now, children, tracers. What are the tracers, children, here? Radio NaCl and a radio iron, radio iodine. So here I am putting a star mark here, which means you should think that they are radioactive in nature. These 3, radio sodium chloride, radium iron, radio iodine, these 3 are called actually tracers. What is the purpose of these tracer, children? So in any emergency situation, any accident takes place, so there might be clots may formed in a blood, and even tumors might be formed in the brain. So to identify the tumors in the brain or even clots in the blood, these tracers are used. Clear? Fine. And during a surgery, children, yes, doctors will use syringes, some other, some equipment related to the operation theater, So after that, they have to clean it actually. In general, normal methods, so what they do, so they'll boil the water. So in that, they'll keep all the equipment. And after that, they'll take out, again, they may reuse actually. But thing is that process takes a lot of time. It's not that much reliable actually. So for that only, we are going to use the gamma radiations to sterilize the syringes and other equipments related to the what we can say operation theater and medical field, let us say that. So the method whatever we are following by using these radioisotopes, it is it's a very quick process, very quicker it is, and as it's quick it takes less time. It's a simple method and it's a more reliable. So these are the medical field. Come to the scientific application, children. So we know that here radioisotopes, they emit alpha particles, right? They also emit alpha particles. So the whatever the alpha particles which are emitted from the radioactive isotopes, they are used as a projectiles in a nuclear reactors. Done? Fine. And same alpha particles means what are the alpha particles which are emitted from the what radioisotopes, they are used to estimate the size of the nucleus. That is what actually Rutherford did, right? So alpha ray scattering. So with the help of alpha rays only, what happened, children? He could estimate even he could prove the positivity, that is the positive charge of the nucleus. He proved that yes, nucleus has positive charge. So with the help of what? With the help of alpha particles. Am I right? Fine. And come to the, so here our scientists, in agriculture scientists, they use these radiations, whatever the radiations emitted from the radioactive isotopes, they are used to find the growth of the plants. Fine. Next are archaeology department people. So generally, archaeology people, they will estimate the age of the rocks, age of the buried plants, So that method only we can call it as a carbon dating. That we can call it as a carbon dating, where they'll use C614 to estimate or to know the age of the rocks and age of the buried plants. Okay, na? So these are the scientific applications. Comes to the industrial applications, children. So we know that uranium-92-235 is an isotope. So we have one more thing. What is the uranium-92-238 also we have. So in general, uranium-92-235, this is used as a fuel rods, very important, where in a nuclear reactions in the production of what, children? Electricity. Clear? Fine. This is for a electricity purpose in a nuclear reactors. Fuel rods, but where? Nuclear reactors. And children, in a big factories, what will happen, the parts of the machine all are in motion, moving here and there. So due to that, what will happen, yes, there is a chance of accumulation, there is a chance of accumulation of charge on the moving parts of the machine. So which may cause us to some dangerous things actually. Then how to remove the charges which are accumulated on the moving parts of the machine? So there also we use the radiations which are emitted from the what, children? Radioisotopes. So finally, yes, whatever the radiations, especially beta radiations, which are used to control the thickness of the paper. So we are getting all notebook papers and all these things, if you can see, they all are same in, thickness. Am I clear? Same in thickness. So they are controlled, I can say. So the thickness of the paper, thickness of the plastic, some other things, can be controlled with the help of radioactive radiations. I mean, the radiations which are emitted from the radioisotopes. Clear? Just note down. Now we discuss the source of harmful radiation. Just we discuss the sources of harmful radiation. Done? Fine, children. Nuclear power plant, children. So children, we know that fuel rods which are made up of with the uranium-92-235, they are used in a nuclear reactors in the production of electricity. So if everything goes fine, no problem at all. But sometimes, due to some technical issues, so we should not wish such a thing should happen actually. Okay, fine. So then what happens, there might be a blast in a nuclear reactor core. Then what will happen? So as we are using radioactive material in the nuclear, what we can say, core of the nuclear reactor, obviously whenever there is a blast, so the radiations will come out of that reactor actually. So then it will become, all radiations will be coming out actually, because in that radioactive material will be there, right? So it will be emitting the radiation continuously. So what happens? Obviously that is going to be a source for a radioactive radiations. Clear? And which are very harmful. And the second one, nuclear waste. So children, so as we just discussed that, so some fuel rods are used, like made up of the uranium-92 and 235. They are used in a what we can say in a nuclear reactors for the production of the electricity. But after usage, whatever the fuel rods which we are using, they only we can call it as a nuclear waste. Children, try to understand, means they will be using these fuel rods continuously. After some days or after some months, depends on the size and all these things, what will happen? Their activity will get decreased, which means what? For suppose initially they are giving 100% of the radiations, let us say. After few days, they may give like a 5%, 10% actually. So in that situation, so they are not useful to produce enough heat so that we can produce enough electricity. Then what will happen? Those rods are rejected. So nowhere they will use in nuclear reactors. At the same time, you cannot throw wherever you want also, because they also might be 10%, might be 5%, might be 1% what ability they have to emit the radiations, but still they are harmful only. They are harmful only. Okay, na? So whatever the nuclear rods which are rejected, they only we can call it as a nuclear waste. Means when their activity gets decreased, only they are rejected, and we have to follow the particular methods to do what we can say disposal and all these things. Clear? Fine. And the third one is cosmic rays, children. So it's a cosmic rays. So we know that these are the rays which will be coming out of coming from the outer space. The thing is that these cosmic rays will carry so many types of what we can say charged particles. Charged will be there, uncharged will be there. But really we are very blessed, children. Let me tell you, if it is the earth, means try to understand earth. Around the earth, one invisible magnetic field will be there, which will reject almost all charged particles which are coming along with the what we call cosmic rays from the outer space actually. But the thing is that okay, it can only what we can say it only can stop all these charged particles. But if you can see, gamma, X-rays will be there. So they are not charged particles. So obviously they will enter. So that's what we can say, that even cosmic rays also like a source of this harmful radiation. Only we have three, children. Three only. Radioactive fallout from a nuclear power plant and nuclear waste. Third one is cosmic rays. Now we see the harmful effects of these radiations. Harmful effects of these radiations. Fine. Now look at here. So harmful effects. The first one is short time. Children. Or short term, let us say. Short term it is. So short term, children. Which means what? So the particular person who gets exposed to the radiation, he might be having health issues, but that can be curable. So it is a, try to understand. Here the person can get recovered easily. The person health will become very fine. It may take some days, weeks, months, but it can be curable. The short-term things, short-term problems, whatever a person will get, those things can be curable. Fine. And here second one is long-term it is. Second one is long-term here. So here, whoever the person, he gets exposed and he'll get a problems. So may not be, it's not curable, not may not be. Damn sure it is not at all curable. Means it may continue till his death. Finally, the person will die. Try to understand. Okay, no, fine. And third one, permanent. Here only persons will get a doubt actually here. Sir, in a long term only person, it leads to death, right? After one person will die, again what will be there to continue permanent? So let me tell you, these two are only for individual person it is. Means individual person only will suffer here. Individual person will get a problem and it is a curable. The individual person will get a problem, it is not curable, he will die. But what are permanent, yes, in some very rare cases, what happens, so that problem will be continued to the generations. Means there will be a modification in the genes of that particular person, so that will be carried to generation. Yes, you can see in the case of Hiroshima and Nagasaki, what happened years back it happened, but till date, who are the the newborn babies also, they are going to have a little bit defects, might be physical defects or mental defects, all these things will have. Is it clear? So try to understand this short term, long term, it goes with only one particular person. It will end with one person only. But here permanent one, it will be carried to the generations. Okay, na? Just copy it. Children, now we discuss what are the precautions to be taken while handling the nuclear energy. So precautions to be taken while handling the nuclear energy. Here we have three stages, children. The first one, what are the precautions to be taken while establishing the nuclear power plant? And the second one, what are the precautions to be taken, directly for a person who are working in the nuclear reactors? Third one, what are the safety disposals. This is also very, very important. Okay, fine. So first one, when it comes to the establishment of nuclear reactors, So first one, the common thing is what, children, here? Yes, they must be, again I'm telling you, nuclear reactors must be set up where? Within the city? No. So they should be set up far from the populated areas. That is a very, very important. Clear? Okay, fine. And the second one is that, so what are the core of the nuclear reactor will be there? That must be shielded with the lead completely. Why only lead? You know, children, because lead has the ability to absorb the radiation. Somewhat extent it can control. Clear? Fine. And third one, even children, that entire setup will be there, you know. So that must be with a, you know, covered with a very thick concrete wall. Whatever the nuclear reactor power plant will be there, completely it is surrounded by a what we can say very thick concrete wall. So concrete wall also has ability to stop somewhat radiations. Clear? Fine. And the fourth one, yes, there must be always backup cooling system. Very, very, very important. So there must be always backup cooling system. Why backup cooling system, children? Yes. So we know that here nuclear reactor is what, children? It is nothing but, you know, steam engine. It can produce only steam. It is a steam engine, right? So obviously continuously heat is produced. And continuously the core of the reactor must be cooled actually. Try to understand. Okay, now fine. So these are the precautions to be taken while handling the nuclear reactors. Now second one, let us see that. So what are the precautions to be taken by a persons who are working? Because the person who are working in nuclear reactors, obviously they'll get exposed to these radiations. Okay, now fine, children. So we'll see the precautions to be taken by the person who are working. Children, the very important thing is that the persons who are working, you know, they must be provided with the lead gloves and lead lined aprons, so that what we can somewhat extent the radiation will be stopped. Means they must be provided with the lead gloves and lead aprons. And the second one, children, here what we can say, yes, so okay, they might be provided with you know, gloves and everything, still they shouldn't touch the radioactive material. For that, what, long lead tongs should be used. It's very important. It's a long lead tongs to be used. Okay, now fine. And still, in spite of these precautions, still the person definitely they'll get exposed. Then till what extent the particular person gets exposed to the radiation, that should be measured. For that, the persons must be provided with the safety badges. Safety badges. So with which we can measure the percentage of exposure to the particular radiation actually. Okay, children. So this should be taken. Fine. Then how to do this safety disposal? What are the safety disposal for this? Children, as I told you that what are the nuclear waste we will get from the nuclear reactors. Okay, now. So how to do that disposal? You cannot throw. Generally, some irresponsible persons will be throwing the dust simply in outside of their houses. So like that also you shouldn't do that actually. Is it clear? So the best method is that this nuclear waste must be placed in a lead casket that must be taken to the far from the populated area. There, a special earth must be dug and special construction must be made actually, and there it must be buried. So this is the best method for this safety disposal. Is it clear? Fine. So these are the safety precautions while handling the nuclear energy. So here we have three stages. The first one is precautions to be taken while establishing the nuclear reactors. Second one is the persons who are working, and third one is safety disposal. The final one is background radiations. Children, what are the background radiations? The radiations which will be present, in a particular area, but radioactive material won't be there. Radioactive material is not visible little. Such a radiations are called actually background radiations. What didn't understand? Let us take one example. This example might be funny, children. So just example for your understanding. Should not write an exam. So for suppose in a particular room, particular house, let us say that what happens? Nice food is cooked, kind of biryani type, spicy biryani type. Okay, it is cooked, and it is cooked, and after cooking that is taken from some other XYZ area. Let us see that. And if any person will come from outside to that particular house, do they feel some kind of smell of that biryani? Obviously, they think that yes, somewhere a biryani is placed. If they'll search throughout the full house also, they won't find. Actually, the smell is from where actually biryani smell. The biryani is a source, but the source is not visible in that house. But still, the smell will be present. So that smell only we can call it as a background smell. It is okay. Fine. Just comparison I'm telling, which means what here? Sometimes radioactive material is not visible, children, but still radiations will be there to which we get exposed. So the radiations to which we get exposed, even radioactive metal is not visible, or called actually background radiations. Here we have two types of background radiations. First one is internal. We have internal background radiations. So children, here the radiations which are present within our body, we can call it as a internal background radiation. So here example, if you can see here, yes, carbon 14, yes, it is a present only. Next, potassium 40 comes under internal background radiations. And here the second one is external background radiation. So here example means, children, yes, we can say the cosmic rays, and here is radon 222. So these are the background radiations. And here in exam, important question might be asked. So is it possible to keep our body out away from these radiations? No, it is not possible. Highly impossible. We cannot keep our body away from the radiation. Yes, somehow we'll get exposed. Hey, here in fact these two are present in our body only, right? So how can you keep our body away from the radiation? So it is not possible. So children, with this successfully we completed unity of radioactivity. So what we covered today chapter, children? Yes, we covered what are radioisotopes and their applications. Then we discussed the source of harmful radiation and the harmful effects of radiation, and finally of course we discussed the the safety precautions while handling the nuclear energy. There again 3 stages are there while establishing the nuclear power plant, the precautions, while the persons who are handling the nuclear energy, and third one is safety disposal, the finally background radiations. So children, in the next class we will be doing the unit B of the radioactivity chapter. Okay children, thank you so much. All the very best.